There we go. Thank you. So the NSF published this remarkable paper back in 2003 called NBIC Convergence, and in which not only did they outline the kinds of technologies that are soon to arrive that will dramatically alter what it means to be human, but they actually were in support of this. This was what they hoped would be opening up the conversation for what they thought would be the accelerating convergence of all these technologies for enhancing human performance across all fields. And this was a bit of a like a hand grenade went off, and it created quite a ruckus, both in terms of the advocates for it and in terms of its critics. What they argued was that there were going to be a number of key technologies that will converge together to really create this new human. Psychopharmacology, genetic engineering, nanotechnology, artificial intelligence, and the cognitive sciences. And like I said, they were supportive of this, but they were soundly criticized by the more conservative quarters. Now, many of you might be asking, and I have touched upon some of these issues already, when it comes to talk of transhumanism, to what end? Why? Why bother? I mean, why are we not fine the way we are? And I'm sure that's typically the number one concern that I hear for those new to the suggestion. As I thought about it, I came up with really 5 different ways of justifying it, I think, where it not only just becomes not just a frivolous want, but rather an important ethical issue, an important legal issue, and an issue of social justice. It comes down to our reproductive rights, our morphological freedoms, our cognitive liberties. It becomes an issue of reducing suffering and maximizing human experience and potential. And I'm now going to shift. Actually, I'm going to go back just a little bit. I kind of skimmed over that too much. What do I mean by reproductive rights? Well, it's not just things like the right to birth control. It's more profound things like IVF, in vitro fertilization, which back in the day, in the 70s, many of you will remember, the brouhaha that erupted over test tube babies, and how this was going to usher in a brave new world, and a whole political lobby emerged in opposition to this. The hysteria about it was quite intense. And now, today, we no longer refer to it as test tube babies, we call it IVF, and just last year, 200,000 Americans were born in this particular manner. So it is reproductive technologies as well, and it will in the future encapsulate such things as genetic modifications, designer babies, cloning, and other types of novel interventions in our reproductive processes. Then there's issues of morphological freedoms, things like cybernetic enhancement, life extension, and cosmetic surgery. Any changes that I deem fit to my own body, if I want to change my body. And again, it could mean even things like radical body modification to things like tattoos, or changing the pigment of my skin or hair color. These are all different ways of applying these sorts of technologies. And interesting is that the radical body modification people have very much caught on to the whole transhumanist thing. When we had our conference here, our international conference in 2004, we had a community of the body mod group come out, and they were interested to know how can they change the color of their skin. How can they kind of twist what's normal in terms of morphology. It was really quite fascinating. Cognitive liberties, things like enhancing your IQ, your memory, having alternative psychological spaces and experiences alternative psychological spaces and experiences, a shift away from what is heretofore regarded as neurotypicality. Reduce suffering, reducing the ravages of aging, better pain management, alleviating such problems as that disease causes. And when it comes to maximizing experience and potential, there's the reduction of genetic arbitrariness. That we find the genetic lottery to be arbitrary and repugnant. It's an issue of social justice and a way to further democracy. To see lives flourish, not constrained by disability or latent biological limitations. And now I'm going to shift to the subset of transhumanism, and that is life extension. More appropriately, radical life extension. And to that end, that would qualify, I guess, here under morphological freedoms, the right to preserve your body at a particular state of being. That one would also argue that life extension is a way to reduce suffering and the ravages of aging, and even, of course, the stress of facing our mortality and dying, and even reducing the suffering of those around us who don't want to see us go just quite yet. And of course, maximizing human experience and potential. That doesn't really need much of an elaboration aside that you can't really do much. You can't really maximize and experience much when you're not alive. Okay, what is life extension? And this is surprisingly prone to a lot of misunderstanding. Ultimately, it's about significantly expanding the length of healthy human lifespan. It's about slowing down or even halting the aging process. What has been called negligible senescence. Senescence being a fancy word for aging. And of course, negligible meaning barely noticeable. So a state of being where our aging is barely noticeable, where we're basically at a fixed age. Now, it is not about extending decrepitude, and this is a common misconception. The idea that what we're talking about is, that's a great word. Every time I have an opportunity to use the word decrepitude, I'm there. Yeah.
I love it.
Yeah. That we're not talking about what Francis Fukuyama, actually probably the world's #1 opponent of transhumanism, would call the creation of a nursing home world. We're absolutely not talking about that. We're not talking about extending aged people to even more extreme levels of frailty. It's about, again, not just slowing down and halting the aging process, but actually achieving a biological age that's desirable. I would say, for me personally, perhaps 24, but that's up to you. And ultimately, it's also about making death a voluntary choice. And this is another idea, is that everyone gets all upset about the idea of everyone living forever, or could you even say that we would live forever? And transhumanists, as a result, tend to shy away from such terms as forever and immortality, and prefer such terms as negligible senescence, and even talking about death as a voluntary choice. So basically, death no longer being an imposition, but rather something that we'll decide when it is right for us after, let's say, maybe 500, 1,000 years, 10,000 years. Who's to say that that's enough? It's time to perhaps part with this mortal coil.
Part with this immortal coil.
Part with this mortal coil.
Immortal coil.
Part with the
Immortal coil.
mortal.
It's not mortal if you're not aging anymore.
I mean, that's true. You can part with actually, you're absolutely right. Parting with the immortal coil. Yes. We are in the midst of this revolution right now, and there are 3 waves in which a radical life extension will come about. One has already happened, and the 2 are yet to come. The first wave happened in the 20th century, when at the dawn of the 20th century you had a life expectancy in and around 40 to 45 years old. By the end of the 20th century, it was not uncommon to see people living well into their 70s and 80s with regular frequency, if not even further. Why did this happen? Well, we had a number of conceptual breakthroughs in health, namely better hygiene, medical advances such as surgery. We started to develop more sounder ideas as it pertained to germ theory. And of course, we have vaccinations. And by the way, I'm imagining, and I'm certainly hoping that everyone in this room is vaccinated. And if you don't think that transhumanism is coming, or that even you yourself are not a transhuman, you are absolutely transcending your limits of human biology by having vaccinations. You have a super immune system. You are immune to some rather dreadful diseases that are out there, such as polio and smallpox and the like. So you are already an enhanced human. But you accept it, I'm sure, and I'm sure many of you would not want to part with that super immune system. And what we're really talking about here, why I address this, is that this is a normative issue. Is that what might seem radical and extreme in terms of the kinds of abilities or immunities that we may have in the future, that by today they may seem extreme, tomorrow we will take it for granted. Now, there are 2 waves coming. One is quickly coming upon us, and the third will happen perhaps about half a century from now. The biotechnology revolution is certainly in full sway. We had the breakthroughs in mapping the human genome back in the 90s, and that's basically started a path toward us getting a handle on our biology. And then in and around 30 to 40 years from now will be the nanotechnology revolution. And I focus on nanotechnology in particular because it will take us to the next phase where we will in fact achieve this heralded state of negligible senescence. And I'll talk about each of these in detail. Okay, the second wave. At a broad level, we're going to develop the tools to reprogram our biology and its biochemical information processes. So in other words, getting a real handle on our biological makeup. What makes us tick? But not only what makes us tick is understanding why these processes work, how they can be refined, modified, fixed, improved, and so on. As it pertains to life extension, the biotechnology life extension it really got started in the 70s, in the early 70s, when you had the American Aging Association formed under a fellow by the name of Denham Harmon, and he actually put forth the first idea of the free radical theory of aging. The free radical idea is that we have junk in our cells that are causing stress to our bodies that ultimately results in the aging process. Part of the aging process. Aging is a multifaceted problem that's a major contributor. In the 1980s, we had a book by Saul Kent entitled The Life Extension Revolution, and Saul Kent went on to talk to actually found the Alcor cryonics group, which that's a topic for another talk, which is the whole idea of cryonics, and that's preserving people for eventual reanimation, that people upon death, they get stored in liquid nitrogen in hopes that a future civilization will bring them back to life. I guess that's a kind of life extension, but it's not one that I want to talk about here. I want to talk about avoiding that altogether. But the cryonicists are apt to point out that being preserved in a vat of liquid nitrogen is probably the second worst thing that can happen to you. And then in 1983, Dr. Roy Walford, a life extensionist and a gerontologist, published a popular book called Maximum Lifespan. So he had these kind of seeds set in the 70s and 80s for what has now emerged as modern biogerontology and a kind of a paradigm shift in the medical sciences and how we view aging. It has spawned the careers of a number of biogerontologists, thinkers like Aubrey de Grey, Cynthia Kenyon, and Michael Rose. And these theories are more radical than ever, and a sea change is occurring in the medical sciences where we're now looking at aging. We're looking at aging and how it's perceived as a disease that can be cured, or at the very least a set of diseases that can be cured or solved. It's an engineering problem to be solved. And there's a huge potential for regenerative medicine and true anti-aging interventions, which I will get into in more detail a little later. Here's the big guy, Aubrey de Grey. I'm sure many of you have recognized this face. Very much the spokesperson and very emblematic of the life extension movement. He is I believe he's at Cambridge, and speaks with an extremely thick English accent. At least initially I had a hard time comprehending him, but I'm becoming quite much better at it. And of course he's very famous for the very long Methuselah beard. But he came up a number of years ago with what he called SENS, or Strategies for Engineered Negligible Senescence. And he came up with 7 different causes for aging. He isolated them. And he came up with a pretty good list. These are 7 nasty things that happen to us, and I'll just quickly go over them, and not in any great detail. But things like cell loss or atrophy cell depletion, nuclear mutations and epimutations, mutant mitochondrial problems, death-resistant cells, extracellular crosslinks, junk outside cells, junk inside cells, things like telomerase fraying. Very technical stuff, but ultimately what's exciting about it is that they've nailed it, that they've figured it out, what it is about aging that causes our cells to age, to regenerate, to have copy problems. And that's the first part of the problem, is being able to phrase the problem. And now the next step is to actually go about, as Aubrey would say, is to create this engineered negligible senescence. But ultimately why that's important, why I've got Aubrey's face on here, is that he's helping put forth this idea that aging is not an inexorable process. It's not something that just happens and we have to deal with it and we can never do something about it. It is a process not unlike any other that happens in the human body, and given the right tools and the right know-how, it can be something that can be tweaked a little bit and perhaps halted altogether. How we'll come about this? Simply to further our sense of biotechnology and understanding of the human body. And there are already some technologies emerging that will help us along this path to help Aubrey and others do what they want to do. By the way, just as an aside, Aubrey has what's called the Methuselah Foundation, and you may have heard there's even a thing called the Methuselah Mouse Prize. And what they do, I believe it's on an annual basis, they do award an award to the clinical lab that has extended the lifespan of a mouse to the next maximal degree. So you have a bunch of labs around the world where they're experimenting on mice, giving it genetic tweaks, altering its diet, exposing it to different sitcom comedies. I don't know. But ultimately what they're trying to do is figure out how they can extend the lifespan, the maximal lifespan of mice. And they've done some pretty scary stuff in terms of extending lifespan to a twice its normal lifespan and so on. And I'm looking forward to the day. I mean, many people may leave here, and certainly those that I speak to on a regular basis shake their heads in denial about this, but won't it be a remarkable day, a miraculous day, when we finally have that mouse in the lab that just simply refuses to die? It'll be akin to Dolly the sheep being cloned, perhaps even more so. It'll be a powder keg that will go off to change a lot of minds, but it will happen. I'm not sure when, but I'm sure it will. The kinds of technologies that will help this come about, already we have regenerative medicine. Everyone's familiar, I think, with stem cells and the potential for stem cells. Well, what I can say is believe the hype. It's all true. It's all real. Stem cells have incredible potential for what they can do for to heal and to solve problems. I believe, for example, I know for a fact that they've actually, what a stem cell is what's called a pluripotent cell, or an undifferentiated cell. It's a special cell in our body that hasn't grown up yet, doesn't know what it wants to be in life. But given the right context, given its association with other cells, let's say a heart cell or a bladder cell, it says, okay, I know now what I want to be when I grow up. I want to be a heart cell. And it's, again, a lot of voodoo goes on in the background that we're not quite sure of as of yet, and it just simply knows what to do, where to go, and how to do it. And basically the lab technicians stand back and they watch the cells create a heart. In this case, it was a rat heart. And as well, they also gave it electrical stimulus that it would pump like a normal heart, and they have a heart emerging in the lab. I also believe, and I'd like to get the proper reference for this, but I've heard they've also snapped the spinal column of a mouse, and they've regenerated it with stem cells.
Just suggest you need to explain the basis of this, that differentiated cells are only using a portion of the genome.
Yes, it's again that basically all the cells that come about in our body are from undifferentiated cells, correct? That is part of genetic expression.
What I'm saying is that differentiated cells
right.
are only utilizing, they've been programmed to utilize only a portion.
There you go, thank you. Fair enough.
So, in principle, a differentiated cell can be reprogrammed back to be pluripotent. I think that's one of the avenues.
And I think I have heard along similar lines that where a lot of the controversy comes with stem cells is not what we're going to do with stem cells, is where we get them from. That traditionally we get them from embryonic fetal matter. And there's some exciting work being done now. I personally have no moral compunction against that, but many obviously do, and that's why it's a huge political issue. But anything we can do to make something less political and actually start to get to real science and really helping people, I think is a good thing. So the fact that we can now extract stem cells from non-embryonic fetal tissue is a good thing. Also the potential for cloning, whether you love it or hate it, cloning is coming, and I think it's probably a non-issue. I think the number of people that would actually choose to clone themselves would be minuscule and probably would be lower than the amount of people that use in vitro fertilization. There's also the potential for real anti-aging supplementation. Again, I put these on the board here because these are actually coming very soon, if not already. Anti-aging supplementation. First of all, if anyone ever peddles something to you right now that promises to be anti-aging, they're lying. Nothing exists right now. But that is set to change. There is a company in the United States that has managed to isolate the only true anti-aging enzyme that has been found. And for those of you that drink red wine, you may be aware of this. There is a chemical compound, an enzyme in red wine called resveratrol. And it has been shown to have anti-aging qualities, that it actually does slow down the aging process to a very minuscule degree. It may also in part explain what's known as the French paradox. The French eat a very high-fat diet, high cholesterol, a lot of cheese, but as we know, they love a glass of red wine, but for some reason they have a very low rate of heart disease. And the belief there is that it's the resveratrol component in the red wine that's contributing to their good health. Well, the trouble is, if you want the kind of life-extending qualities that we're talking about in terms of real potent anti-aging, you would need to drink 1,000 bottles on a very regular basis to get the amount of concentration required. Obviously not possible. Maybe for some of you it is possible, I don't know. But there is a couple of guys in the United States, they've managed to find a way to concentrate this compound, resveratrol, into 1,000 times this potency, into a pill format. This pill exists today, and I'm sure those two guys are popping them on a regular basis. But it's still in clinical trials, and it'll be about 5 years before we see this hit the market. And once it does, that will be the first true bona fide anti-aging supplementation that you can take. So look for that, and I believe it'll be branded under the name Serotin. I can certainly confirm that for you later, but I think it's going to be called Serotin. So that's the second wave, biotech. The third wave is a bit more radical. This is where we get into that post-humanistic stuff, that post-biological stuff. And that is rebuilding our bodies and brains at the molecular level and fixing the remaining problems that are difficult to address within the confines of biology. And then ultimately going beyond the limitations of biology altogether and creating new states of being and new ways of biological, or post-biological functioning. That's a carbon nanotube, by the way, all you geeks out there. Now I'm going to focus on nanotech. Again, I could focus on perhaps the other biggies in and around this time, in around 40 to 50 years from now, but again, I think it would largely be outside the scope. I could talk about artificial intelligence and its impacts in terms, for example, of such things as whole brain emulation, the idea that we could actually copy the human brain, but not just copy it, but put it into a different substrate, like a digital substrate, the so-called upload, where we live a virtual reality existence. This is all part of the potential for post-humanity. But I want to kind of keep it at least embedded in terms that we can really perhaps grasp onto a bit better, and that is what nanotechnology can do for us in terms of re-engineering how our bodies work. Now, what is nanotech? Let me just kind of briefly explain just the kind of scale we're talking about. Yes, we're talking about moving matter at the molecular level, but just how small is that? The best way of imagining it is to take a dime and look at its thin end. Now slice that up 1,000 times. Take one of those slivers and now divide that yet another 1,000 times. You are now down at the nanoscale. The fact that we can actually manipulate matter at this scale certainly defies my imagination and my thought, but it's actually being done. IBM, they've been working on it. They actually wrote with several molecules the logo IBM a few years ago, which is pretty famous. That got a lot of people interested in it. And just today, just while blogging, looking around the blogosphere, they've actually, with several clumps of molecules, made a happy face. That was really interesting. So they're doing it. That's about all they can do right now. But the idea is that we'll be able to work at that scale, not just to make materials. And they're already, for example, there's the famous stain-resistant khaki pants that's made with molecular materials and nanotechnology. Yeah, this is true. But materials will be one significant aspect. But what's going to be more remarkable is when we get into molecular machinery, and then that is the actual creation of robotics or machines at the molecular scale. And I'll go into this now. But this guy, he's a really smart guy, Robert Friedis. He's been around forever. And he's actually speculated about a whole bunch of things, including extraterrestrial intelligence and astronomy and other issues. But he's most famously known for his speculations into what's been dubbed nanomedicine, whereas nanotechnology is applied to the medical sciences. And he has actually designed, he's sketched it on his blueprints, schematics for the kinds of structures, the kinds of machines that we'll want to build at this level, and what they could do to supplement human functioning. For example, actually I'm going to back up just a little bit. Before we even get to Robert Friedis, a bit of context for nanotechnology. It was first conceived in the late 1970s by Richard Feynman, the famous physicist, but it was more fully articulated in the early 80s by Eric Drexler in his seminal book, Engines of Creation. And there, again, the difference between materials and molecular assembly. But the implications of integrating nanotechnology will be quite monumental, and again, it's going to have direct applications to the anti-aging application. Okay, red blood cells. By the way, if anyone kind of disbelieves that there are machines that can exist at this scale, you need to realize that a lot of the components that exist in your body at the microscopic level are not, they're simply that. They are machines that exist at the nanoscale. They work, they function according to physical principles and laws of mechanics. And the idea here is that we will start to make our own devices to supplement these existing ones or to fix the ones that are perhaps degrading. So, as I said, Friedis here has kind of come up with his own set of molecular robots. The one that he's come up with is a Respricite, which is a red blood cell supplement. It's an oxygenating micro machine. I'll get into that in just a second. And then there are T cells, which are microbivores, which destroy microbiological pathogens found in the human bloodstream that what he calls digest and discharge protocol. And then there are actual cell repair mechanisms, devices that go through the body and actually repair, set up scaffolding, and repair damaged cells. Now, I want to focus on the respirosite because it's the most coolest thing that he came up with. It's an artificial red blood cell. It would have an 18 billion atom structure, and it would give off 300 times the amount of oxygen that an organic red blood cell can carry. Why would we need such a thing? Well, exactly. Well, I'll get to that in just a second. From a medical perspective, you could have a heart attack, and your heart would stop beating completely. And you'd realize it at some point, and you'd think, I should probably visit the doctor and tell them that my heart has stopped. Because what has happened is that your respirosites have taken over. They're now taking over where your heart has failed. And it'll buy you an hour or two. You'll go to your doctor and say, Doc, I think my heart has stopped. And then he'll take the next steps required to fix you up, probably an artificial heart of some sort. So it would be an oxygenating compound that would work in that way, again, as a supplement to our more natural occurring red blood cells. As Tallman noted, it could also be used in athletics, where you could run something like a 100-meter dash and not even have to take a breath. It could have profound implications in terms of deep sea diving and our ability to hold our breath underwater for an extended period of time. It would also eliminate the bends, I believe. And it could work to preserve living tissue. Oxygenating processes are definitely a part of aging and how living tissue works. And it would also provide treatment for things like anemia, choking, lung disease, asphyxia, and other respiratory problems. So this one little guy here has got some great potential. Now we can get to some real cool futuristic stuff here. Talking about virtual reality and mind uploading and such ideas. Is the nano-neural network, is the idea that eventually we can suffuse the brain with nanobots. Well, why would we want to do that? And here's an interesting scenario, perhaps might make for better science fiction today than reality, but it's one of the most interesting scenarios for the creation of virtual reality that I've ever heard. We are as conscious agents, of course, outside of our senses, we are we have a thinking part of our consciousness, that self-aware aspect, the narrator that is us. But very much as part of what is our conscious experience is the sensory data that comes in, the five senses. And those five senses are coming in through our eyes and so forth, our ears, and they're all going to their the signals, those are all signals that are being interpreted at a specific part in the brain, whether it be the cerebral cortex, the audio cortex, and so forth, the visual cortex. What it is doing is it's converting the information coming into the environment into a signal that the brain can understand such that it translates it to you, that you experience as your subjective reality. What a nano-neural network would do is these devices would suffuse the brain and occupy themselves in and around the areas of your brain that perform these functions and stop the signal. It would be a roadblock. So all audio information stops, all visual information will stop, taste, all those sorts of things. It'll hijack those signals and stop them. And then perhaps another nanobot in the same area will then, in its place, now transmit new signals, new audio information, new visual information, and so on. That's completely different and separate from the information you're getting from your environment, thus creating a completely different reality than you are engaged in. So in other words, it's fooling your senses utterly and completely, and you would be absolutely unaware that you are in fact in a different environment than your body truly is. This of course brings together some real interesting philosophical and existential issues. How do you know right now, for example, that you are not a part of a neural nano network? It brings together some Cartesian issues, brain in the vat type problems. But certainly, if we are going to think of ourselves, and again, this is a big part of transhumanist philosophy and post-humanist ideas, and it's certainly no stranger to science fiction with such things as The Matrix and other snow crash